To re- I'm going to represent the problem 5 continuous bag of words or CWO from the scratch for the source learning vectorial representation of the word. The main objective of this problem is to implement the CBOW word embedded model from the scratch without using a pre-built word embedding library. In our experiment, and we use the text corpus with a vulnerability size of 5,000 words and are embedded dimensions of 100 and 5,000 50,000 training instance. The basic idea behind CBO is to predict a center word from its surrounding context word. For example, if the sentence contains a target word embedded by the several words, CBO takes the surrounding word as an input and tries to predict the missing center words. In the first step, the model takes the embeddings of all the content words and calculate the average. This produces the hidden representation of the context. If there are the multiple content words, their vectors are added together and are divided by the number of context words. Next, this hidden context vector is multiplied with the output weighted matrix to produces a set of codes called logistics for all the words in vocabulary. Since our vocabulary contains 50,000 words, the model produces the 50,000 outputs. These codes are then converted into the probability using a softmax function. The softmax gives a probability distribution over all possible words. The probability of the current centered word is then used to calculate the cross entropy loss. The objectives of the training is to reduce the loss so that the model becomes better at predicting the center words from this context. After the forward pass, we perform a back propagation to update the model parameters. The difference between the predicted probability and the actual target word produces the output error. For these error, we calculate the gradient of the output weighted matrix and the hidden layer. We then propagate the gradient back to the input word embedded and update the embedding of the context word. One important observation from our experiment is the softmax denominator bottleneck. The softmax calculate requires us to calculate an exponent values and their sum across the entire vulnerability. More than 50% of the forward passes times are spent calculating the denominator. This experiment demonstrated an important limitation of the standard softmax approach. Because of the model has calculated the probability of every word in the vocabulary, the computation cost becomes a higher as the vocabulary goes. This is why the more efficient techniques such as the negative sampling and hierarchical softmax are used for the training word embedding models. The implementations are done using the Python and NumPy with the forward pace softmax loss calculation. To conclude, our gradient check produces the implementation is mathematically correct. However, the implementation also show the full softmax is computational expert because more than the half of the forward pass time can be spent processing the demo. The negative and the hierarchical softmax are important for the larger vocabularies. Thank you.